Welcome to The Explainer. So if you're anywhere near the tech world, you've definitely heard the term MLOps thrown around. But what does it actually mean? Well, it's the critical, often invisible engine that takes a brilliant AI idea from a lab and actually puts it into your hands as a reliable, real-world product. Today, we're going to pull back that curtain and see exactly how it all works.
So let's start with the central challenge, right? You've got this amazing idea for a machine learning model. Maybe it can spot customer churn or identify diseases from medical scans. Awesome. But how do you get that from a researcher's laptop to a stable application that millions of people can count on every single day? That huge gap between a clever model and a real product, that's exactly what MLOps is designed to bridge.
And the answer, of course, is MLOps, which just stands for Machine Learning Operations. The best way to think about it is this. It takes all the discipline and automation we've learned from modern software development, things like testing and continuous monitoring, and applies it to the kind of unique data-heavy world of machine learning. So if AI is the brilliant invention, MLOps is the factory floor that can produce it at scale, making sure it's not just smart, but also consistent and super dependable.
Okay, so MLOps doesn't happen in a vacuum. Not at all. It's a team sport. To really get it, you need to meet the team. What I like to call the engineering trio, who all have to work together to bring an AI solution to life.
This collaboration is everything. It all starts with data engineering. Think of them as the prospectors. They're out there finding, cleaning, and preparing the raw material, which is data. Then they hand that pristine data over to the ML engineers. This is where MLOps really lives. They're the ones building and training the AI models. And finally, you've got the app engineers. They're the finishers. They take those powerful models and skillfully weave them into the apps we use every day. And you'll notice ML engineering is sitting right there in the middle, acting as the critical hub between the data and the user.
And, this isn't just some simple one-way street. Not at all. It's a dynamic, continuous feedback loop. As soon as the app engineers deploy a model, it's real-world performance data. What it gets right, what it gets wrong. That data gets fed immediately back to the ML engineers. This lets them spot problems, maybe a shift in customer behavior, and then use that new data to retrain and improve the model. It's a living system, totally designed for constant improvement.
So if the engineering trio is the team, then the MLOps lifecycle is their playbook. This is the engine that actually drives an AI project, taking it from a rough idea all the way to a full-blown production system. At its heart, that engine has 6 iterative steps. It kicks off with ML development. That's the fun, creative, experimental phase. Once a promising model pops out, training ops makes that training process stable and repeatable. Then, continuous training keeps the model fresh by constantly feeding it new data. After that, you get to model deployment, pushing it out into the wild where it starts serving predictions. And then, and this is the key to the whole loop, continuous monitoring is always watching its performance. If it sees any drop in accuracy or maybe some data skew where real-world data looks different than training data, it triggers the whole cycle to start all over again.
Now, watching over all of this, you have these 2 overarching processes: data and model management. You should really think of this as the air traffic control tower for the entire operation. It keeps a log of every single data set, every model version, every experiment. This is absolutely crucial for things like compliance, for being able to trace a weird result all the way back to its source, and just for making sure the whole system is auditable and trustworthy.
Okay, theory is great, but let's make this real. We're going to look at an actual platform that puts all these MLOps principles into practice. Google's Vertex AI. It's really the perfect case study for seeing how all these pieces come together. A platform like Vertex AI didn't just appear overnight. Its strength really comes from years and years of evolution at Google. It started with building a world-class data foundation. Then they layered on a super powerful ML toolkit with famous tech like TensorFlow. What we have today is the unification of all of that. A single, integrated platform where data and machine learning can finally work together, totally seamlessly.
So what? Why does having a unified platform like this actually matter so much? This is where the rubber meets the road. We're about to see the real, tangible benefits that a mature MLOps platform gives to the teams that are out there building AI.
The advantage of this whole unified approach really comes down to just four game-changing benefits.
These are the reasons a platform like this can completely change how teams build and scale AI, taking them from slow, manual work to fast, automated, and reliable model delivery. Let's break them down.
The first, and honestly, the most fundamental advantage is unification. It's just that simple. When your data tools and your ML tools live on the same platform, everything gets easier and way more powerful. You just eliminate all that friction of moving data around. It means your ML teams can get way more value from their data, and everybody can collaborate more effectively.
Second, it gives teams true end-to-end capabilities. I mean, think back to that lifecycle we just talked about. A unified platform means you can manage that entire journey all in one place. You can create your data sets, train models using simple automated tools or your own custom code, deploy them and monitor them, all without having to stitch together a dozen different services. It's a huge deal.
The third benefit is this amazing one-two punch: flexibility and scale. Flexibility means you're not locked into just one way of doing things. It supports all the big open-source libraries you already know and love, like Google's TensorFlow or Meta's PyTorch. But at the same time, it gives you access to just immense, scalable infrastructure. You can start small, but when your model blows up in popularity, you have all the power you need to meet that demand. And finally, using a platform like this gives you direct access to the state-of-the-art. It bakes in cutting-edge algorithms and research that comes straight out of Google's own AI labs. So what that means is your team doesn't have to reinvent the wheel. They can stand on the shoulders of giants and use the absolute best tools and models out there to solve their own specific problems.
So as we've seen, MLOps is way more than just a buzzword. It's the essential engineering discipline that makes reliable, large-scale AI a reality. It's the factory floor, it's the assembly line, and it's the quality control system, all rolled into one. And that leaves us with one last really exciting thought. Now that we have the factory for building AI, what incredible things are we going to decide to build next?